Section 1.4 is called Using the Definitions of Trigonometric Functions, and our objectives will be recognizing the reciprocal identity, Pythagorean identity, quotient identity, and signs and ranges of these function values. First, if you look at what reciprocal identities are, we already discussed them on the previous video, so this will be just a repeat of the previous video. Sine is always the reciprocal of cosecant. Cosecant is always reciprocal of sine. Cosine is always reciprocal of secant, and secant is always reciprocal of cosine. Tangent is always reciprocal of cotangent, and cotangent is always reciprocal of tangent. These 6 identities are called reciprocal identities. So here's the first example. If we have the secant of theta is given as 5/3, how can I find the cosine of theta? If I know that cosine is reciprocal of secant, all I have to do is flip over the fraction, so the answer becomes 3/5. Again, if I know that cosecant is negative root 12/2, how can I find the sine of this angle? Sine and cosecant, they are reciprocal of each other. So to find the sine of this angle, all I have to do is flip over this fraction, and then it will give me a -2 over radical 12, which you can simplify to a negative root 3/3. So there's some math going on here. Square root of 12 is 4 times 3. 4 can go outside as 2, and 3 stays. So instead of square root of 12, that's how they wrote the 2 radical 3 here. The top 2 and the bottom 2 cancels out, and your fraction is just -1/3. We can't leave a radical in the denominator, so we need to rationalize the denominator by multiplying the top and bottom by √3, and this is how we get the final answer to this question. We also discussed this on my previous video, the sign for these 6 trig functions on each quadrant. Again, in quadrant 1, everybody is positive. And then if you remember the riddle I was telling you, it only compares sine, cosine, and tangent. Add sugar to coffee. So sine, all of them are positive in the quadrant 1. Sine is positive on the quadrant 1. Tangent is positive in quadrant 3. And cosine is positive in quadrant 4. This is another representation of these signs. Remember, cosine is the x-axis, sine is the y-axis. Determine the signs of the trig functions of an angle in standard position with a given measure. Since 87 is a first quadrant angle, everybody is positive in the first quadrant, so everything will be positive. But for 300, its terminal side is in quadrant 4. And what is positive in quadrant 4? Cosine is positive, but a reciprocal of cosine, which is secant, is positive, and the rest of the things will be negative. What if the angle is in a negative direction? So if you have a -200 angle is given, so this angle lies in quadrant 1, quadrant 2, how do I know? If I find the coterminal angle by adding 3/6 to this, you can find the 160 degree is a coterminal angle, and 160 lies in quadrant 2, so you can think about the signs for quadrant 2. So how would you identify the quadrant for these given circumstances? Sine is positive, tangent is negative. If tangent is negative, but sine is positive, that means cosine will be a negative value. Because when sine is positive, if cosine is negative, then tangent becomes negative, right? So when sine is positive, sine is only positive in quadrant 1 and quadrant 2, but the answer must be quadrant 2 because cosine is negative in quadrant 2. So you will just think about these signs for these given circumstances. It's important to know the range for sine and cosine, very important, especially later in the course. Sine and cosine values, they cannot be lower than -1, higher than +1. So sine and cosine, they are restricted values between -1 and +1. So this is the range in terms of integral notation. Tangent and cotangent, though, for any angle, they can be as low as -infinity, as high as +infinity. For secant and cosecant, there is a difference. The secant and cosecant values will be always between negative infinity to negative 1, or they will start 1 to infinity. So if you can see, there's a gap from a negative 1 to 0 and 0 to 1. So we're going to decide if each of these are possible or not possible. Sine is equal to 2.5. This is not possible because sine values cannot be more than 1. So tangent is 110.47. That's possible because tangent doesn't have any restriction, so it's possible. Secant doesn't like any values between negative 1 and positive 1, so this will be not possible. So we have also this example type that if you have the sine value and then quadrant, we know that angle is in quadrant 2. Can we find the other angles? We will handle them using the right triangle approach. Because if sine is opposite over hypotenuse, opposite side is 2, hypotenuse is 3, you can use the Pythagorean theorem to calculate the adjacent side. And then when you calculate the adjacent side, you will see that the adjacent side is root 5. And then you can calculate the other trigonometric functions by using the SOHCAHTOA rule. But you just have to be careful about the signs. And then when you do that, you can find all trigonometric functions. This is another very important super identity called Pythagorean identity, especially the first one. Sine squared of theta plus cosine squared of theta is always equals to a 1 for any angle. 1 plus tangent squared theta is equal to secant squared theta. 1 plus cotangent squared theta is equal to cosecant squared theta. So these three identities are called Pythagorean identities. We have finally quotient identities that we discussed many times. Tangent is sine over cosine. Cotangent is cosine over sine. So we can just generate the other trig values if we only have one of them. If cosine of theta is negative root 3 over 2 and sine is a positive number, sine of theta is a positive number, can you give the sine tangent? You can definitely draw a right triangle and find the missing functions, or you can use the Pythagorean identity. Since sine squared and cosine squared, they have to add up to a 1. And then you can plug in negative root 3 over 4 for cosine of theta. When you square it, it becomes, there's a mistake here. This is not 13 over 16. This is actually 3 over 16. Or they just calculated sine squared of theta immediately. And then it gives you two values of sine, but you're going to take the positive one because the question was identifying this. This is just a proof that we're not going to look at it here. And I am going to model these examples when we look at the homework question. But you are very welcome to check these examples.